स्वाध्याय टीवी। डॉक्टर बाबा साहेब आंबेडकर ओपन यूनिवर्सिटी।
Today we will see the biography of the prominent statisticians of the world. There are great personalities who have remarkable impact on our lives. As per famous poet Longfellow, these wordings are very much true and inspiring also. Lives of great men all remind us that we can make our lives sublime and leave behind us footprints on the sands of time. In this session, I am inclined to present in brief the life sketches of 4 statisticians who are very famous in realm of statistics. They have done pioneering work in their concerned areas. These statisticians are namely Sir Ronald Fisher, second Carl Pearson, third C.R. Rao, and fourth R.C. Bose. Now we shall have look upon their life sketches one by one. Sir Ronald Fisher. Sir Ronald Fisher was born on 17th February 1890 in London, England. His father's name was George and mother's name was Kate. His father was a successful fine art dealer. He had a happy childhood, being doted by 3 elder sisters, an elder brother and his mother, but she died when he was only 14 years. Ronald had quite a poor eyesight. He was precocious student and won Nil medal for a competitive essay in mathematics at Harrow School at the age of 16 years. Due to his poor eyesight, he was tutored in mathematics without aid of paper and pen, which developed his ability to visualize problems in geometrical terms without contributing to his interest in writing proper derivations of mathematical solutions, especially proofs. He amazed his peers with his ability to conjecture mathematical solutions without justifying his conclusions by showing intermediate steps. He also developed a strong interest in biology and especially evolutionary biology. In the year 1909, he won a scholarship to the Gonville and Calcius College, Cambridge. He learned of the newly rediscovered theory of Mendelian genetics. He saw biometry and its growing corpus of statistical methods as a potential way to reconcile the discontinuous native of Mendelian inheritance with continuous variation and gradual evolution. However, his forecast concern was eugenics, which he saw a pressing social as well as scientific issue that encompass both genetics and statistics. In the year 1917, Fisher was involved in the forming of University of Cambridge Eugenics Society with Keynes, Punnett and Darwin. This was a very active group for research work. In 1912, Fisher graduated from Cambridge. After that, he was very eager to join British Army in anticipation of the entry of Great Britain into World War I, but he was denied due to his poor eyesight. Over the next 6 years, he worked as a statistician for the City of London. He also took up teaching physics and mathematics at a sequence of public schools. During this period, Fisher started writing book reviews for the Eugenics Review and gradually increased his interest in genetics and statistical work. He published several articles on biometry during this period and laid foundation for biometrical genetics. He introduced the methodology of analysis of variance. Fisher was the first person to use the term variance in statistics. After World War I, he was offered position at the Glayton Laboratory led by Pearson, the founder of mathematical statistics in Great Britain. He also accepted a job as a statistician countryside in 1919. It was Rothamsted Experimental Station in Hertfordshire, England. Here he started a major study of the extensive collections of data record over many years. This resulted in a series of reports under the general title Studies in Crop Variation. This was a period of real productivity for Fisher. Over the next 7 years, he pioneered the principles of design of experiments and elaborated his studies of analysis of variance. Even more important study was for statistics of small samples. In the year 1925, his work resulted in his first published book, Statistical Methods for Research Workers, which has become the standard reference work for scientists in many disciplines. In the year 1935, he published very widely used book names The Design of Experiments. Fisher also named and promoted the method of maximum likelihood estimation. He also originated the concept of sufficiency ancillary statistics, Fisher's linear discriminator and Fisher's information, and also Fisher's F distribution. All these contributions made him a major figure in 20th century statistics. He was a prominent opponent of Bayesian statistics, but was even the first to use the term Bayesian. His work on the theory of population genetics also made him one of the three great figures in the field, together with S. Wright and Hendane. He is also considered as one of the founders of the neo-Darwinian modern evolutionary synthesis. In addition to finding modern quantitative genetics, he was first to use diffusion equations to attempt to calculate the distribution of gene frequencies among populations. He pioneered the estimation of genetic linkage and gene frequencies by maximum likelihood methods, and wrote early papers on the wave of advance of advantageous genes and on lines of gene frequency. His 1950 paper on gene frequency climbs is notable as the first application of a computer, the EDSEC to biology. Fisher's groundbreaking book, The Genetical Theory of Natural Selection, published in 1930, gave him unprecedented credit and honor. Fisher had a long and successful collaboration with E. B. Ford in the field of ecological genetics. Fisher was the original author of the idea of heterozygote advantage, which was later found to play a frequent role in genetic polymorphism. Fisher received the recognition of his peers in the year 1929 when he was inducted into the Royal Society. In 1931, he spent 6 weeks at the Statistical Laboratory in Iowa State College in Ames, Iowa. Here, he was in contact with many active American statisticians, including G. W. Snedecor. In 1936, he returned to Iowa State again. In 1933, he left Rothamsted to become professor of eugenics at the University of London. In 1937, he visited Indian Statistical Institute, Calcutta, where P. C. Mahalanobis was working. Thereafter, he had often visited this place, encouraging its development. He was the guest of honor at its 25th anniversary in 1957. In the year 1939, when Second World War broke out for the British Empire, the university tried to dissolve the eugenics department. Then he was sent back to Rothamsted. During this time, he was busy with small projects also. In 1943, Fisher was offered the Balfour Chair of Genetics at the University of Cambridge. He continued his work on mouse chromosome mapping, breeding the mice in laboratories, and other projects. This culminated in the publication of the theory of inbreeding in 1949. In the year 1947, here Fisher confounded the journal Heredity and International Journal of Genetics with Cyril Darlington. Fisher eventually received many awards for his work, and he was dubbed a Knight Bachelor by Queen Elizabeth II in 1952. He was also awarded the Linen Society of London's prestigious Darwin Wallace Medal in the year 1958. After retiring from the University of Cambridge in the year 1957, Fisher immigrated and he spent some time as a senior research fellow at the Australian CSIRO in Adelaide, South Australia. He died in Adelaide on 29th July 1962. Fisher was an ardent promoter of eugenics, which simulated and guided much of his work in genetics of humans. His book on the genetical theory concerned the applications of these ideas to humans and presented the data available at that time. He presented a theory that attributed the decline and fall of civilization to its survival at a state where the fertility of the upper class is forced down. Using the census data of 1911 for Britain, he showed that there was an inverse relationship between fertility and social class. Fisher had written 365 research articles. During his lifespan, Sir James Jeans and F. J. M. Satron were his academic advisors. Fisher had, to his credit, internationally reputed doctoral students like C. R. Rao, D. J. Finney and Wilbur Bodmer. He received notable awards, namely Royal Medal in the year 1933, Guy Medal in Gold in the year 1946, Copley Medal in the year 1955, Linen Society of London's Darwin Wallace Medal in the year 1958. Name of book by Fisher are Statistical Methods for Research Workers in the year 1925, The Genetical Theory of Natural Selection in the year 1930, The Design of Experiment in the year 1935, The Use of Multiple Measurement in Taxonomic Problems in the year 1936, Fisher's 8 tables for biological, agricultural and medical research in the year 1938, The Theory of Inbreeding in the year 1949, Contributions to Mathematical Statistics in the year 1950, Statistical Methods and Scientific Inference in the year 1956. Collected papers of R. A. Fisher of the year 71 to 75 for 5 volumes. Now, we will see the biography of Carl Pearson. Carl Pearson was born on March 27 in the year 1857 at England. More commonly, he was known as Carl KP. His father was William Pearson and mother was Fanny Smith. He was educated privately at University College School, after which he went to King's College, Cambridge. In the year 1876 to study mathematics, and he was graduated in 1879 as third wrangler in mathematical tripos. He then travelled to Germany to study physics at the University of Heidelberg under G. H. Quincke and metaphysics under Kuno Fischer. He next visited the University of Berlin, where he was interested in the works on physiology with other subjects like Roman law, German literature, etc. In the year 1880, he went to Cambridge. He studied law until 1881 and then he returned to mathematics, deputizing for mathematics professor at King's College, London, and for the professor at University College, London in the year 1883. In 1884, he was appointed the Goldsmith Chair of Applied Maths and Mechanics at University College, London. Carl became editor of the Common Sense of Exact Sciences in the year 1885. In 1891, he was appointed to the professorship of geometry at Gresham College. Here he met W. F. Raphael Weldon, a zoologist having interesting problems requiring quantitative solutions. His collaboration in biometry and evolutionary theory was fruitful until Weldon died in 1906. Weldon introduced Carl Pearson to Charles Darwin's cousin Francis Galton, who was interested in aspects of evolution such as heredity and eugenics. Pearson's became Galton's statistical heir, speaking literally. After Galton's death in 1911, Carl Pearson embarked on producing his definitive biography, which was published in the year 1914, 1924 and 1930 in 3 volumes. He by himself financed for these volumes, which later on become famous universally. Carl Pearson then was first holder of Galton Chair in Eugenics at University of London, which was later remembered as Galton Chair of Genetics. He formed the Department of Applied Statistics, in which he incorporated the biometric and Galton laboratories. He remained with the department until his retirement in 1933 and continued to work until his death in the year 1936. Pearson's work was all embarrassing in the wide application and development of mathematical statistics and encompass the field of biology, epidemiology, anthropometry, medicine, psychology and social history. In 1901, with Weldon and Glatton, he founded the journal Biometrica, whose object was the development of statistical theory. He edited this journal until his death. He also founded the journal Annals of Eugenics, now known as Annals of Human Genetics, in 1925. He published the Draper's Company Research Memoirs, largely to provide a record of the output of the Department of Applied Statistics not published elsewhere. Pearson's thinking underpins many of the classical statistical methods which are in common use today. Some examples of his contributions are as under: correlation coefficient. It was defined as a product moment and its relation to linear regression was studied. Method of moments. Carl Pearson borrowed the concept of moments from physics and introduced to descriptive statistics and for fitting of distributions to samples. Pearson's system of continuous curves. A system of continuous univariate probability distributions that came to form the basis of the now conventional continuous probability distributions. Since the system is the complete up to the fourth moment, it is a powerful complement to the Pearsonian method of moments. Chi distance, a precursor and special case of Mann-Ullobis distance. P value, defined as the probabilities measure of the complements of the ball with the hypothesized value as center point and chi distance as radius. Foundations of the statistical hypothesis testing theory and statistical decision theory. Pearson proposed testing the validity of hypothesized values via the p values. The use of present evidence criteria, the so called type 1 error probabilities, was later on proposed by J. Neyman and E. Pearson. Pearson's chi-square test, a hypothesis test using normal approximation for discrete data. Principal component analysis, the method of fitting the linear subspace to multivariate data. Carl Pearson. Carl Pearson was born on March 27 in the year 1857 at England. More commonly, he was known as Carl. His father was William Pearson and mother was Fanny Smith. He was educated privately at University College School, after which he went to King's College, Cambridge in the year 1876 to study mathematics, and he was graduated in 1879 as third wrangler in mathematical tripos. He then travelled to Germany to study physics at the University of Heidelberg under G. H. Quinske and metaphysics under Kuno Fischer. He next visited the University of Berlin, where he was interested in the works on physiology with other subjects like Roman law, German literature, etc. In the year 1880, he went to Cambridge. He studied law until 1881, and then he returned to mathematics, deputizing for mathematics professor at King's College, London, and for the professor at University College, London in the year 1883. In 1884, he was appointed to the Goldsmith Carls of Applied Maths and Mechanics at University College, London. Carl become editor of Common Sense of Exact Sciences in 1885. Carl became editor of Common Sense of Exact Sciences in 1885. In 1891, he was appointed to the professorship of geometry at Gresham College. Here he met W. F. Raphael Weldon, a zoologist having interesting problems requiring quantitative solutions. In biometry and evolutionary theory was fruitful until Weldon died in 1906. Weldon introduced Carl Pearson to Charles Darwin's cousin Francis Galton, who was interested in aspects of evolution such as heredity and eugenics. Pearson became Galton's statistical heir, speaking literally. After Galton's death in 1911, Carl Pearson embarked on producing his definitive biography, which was published in 1914, 1924 and 1930 in 3 volumes. He by himself financed for these volumes, which later on become famous universally. Carl Pearson then was first holder of Galton Chair in Eugenics at University of London, which was later remembered as Galton Chair of Genetics. He formed the Department of Applied Statistics, into which he incorporated the biometric and Galton laboratories. He remained with the department until his retirement in 1933 and continued to work until his death in the year 1936. Pearson's work was all-embracing in the wide application and development of mathematical statistics, and encompassed the fields of biology, epidemiology, anthropometry, medicine, psychology and social history. In the year 1901, with Weldon and Glatton, he founded the journal Biometrica, whose object was the development of statistical theory. He edited this journal until his death. He also founded the journal Annals of Eugenics, now known as Annals of Human Genetics, in the year 1925. He published the Draper's Company research memoirs, largely to provide a record of the output of the Department of Applied Statistics, not published elsewhere. Pearson's thinking underpins many of the classical statistical methods which are common use today. Some examples of his contributions are as under: correlation coefficient. It was defined as a product, moment, and its relation to linear regression was studied. Method of moments. Carl Pearson borrowed the concept of moments from physics and introduced to descriptive statistics and for fitting of distributions to samples. Pearson's system of continuous curves. A system of continuous univariate probability distributions that came to form the basis of the now conventional continuous probability distributions. Since the system is complete up to the fourth moment, it is a powerful complement to the Pearsonian method of moments. Chi distance, a precursor and special case of Manolobis distance. P value defined as the probabilities measure of the complements of the ball with the hypothesized value as center point and chi distance as radius. Foundations of the statistical hypothesis testing theory and statistical decision theory. Pearson proposed testing the validity of hypothesized values via the p values. The use of present evidence criteria, the so called type 1 error probabilities, was later on proposed by J. Niemann and E. Pearson. Pearson's chi-square test, a hypothesis test using normal approximation for discrete data. Principal component analysis, the method of fitting a linear subspace to multivariate data by minimizing the chi distance. Coefficient of racial likeness. In the course of his studies of race, he defined his coefficient calculated from several measurements of the human skull. Carl Pearson contributed heavily to generate new pioneering ideas useful for applying statistical ideologies to different fields. His work is spread up in about 40 volumes and about 40 research articles, which are universally well known today. A few of them can be listed as under: Grammar of Science in the year 1892 by Walter Scott, Dover publication; Mathematical Contributions to the Theory of Evolutions by the Transactions of R.S. of London; A First Study of Statistics in the year 1970 by London, Dallao and Company; On the General Theory of Skew Correlation and Nonlinear Regression, London by Dallao and Company; Tables for Statisticians and Biometricians by Cambridge Press; Tables for Incomplete Gamma Function by London Publications; Tables for Incomplete Beta Function, Cambridge Press; Pearsonian System of Statistical Distributions by Cambridge Press; Awards from professional bodies. He received awards from professional bodies. In the year 1896, elected as Fellow of Royal Society. In the year 1898, awarded Darwin Medal. In the year 1911, awarded Doctor of Science from the University of London. In the year 1932, awarded the Rudolf Virchow Medal by the Berlin Anthropologist Gesellschaft. In the year 1935, offered knighthood, but he refused. He was also elected an honorary fellow of King's College, Cambridge, the Royal Society of Edinburgh, University College of London and Royal Society of Medicine, and members of a Actuaries Club. He received Master of Science degree in Mathematics from Andhra University and Master of Science degree in Statistics from Calcutta University in 1943. He started working at Indian Statistical Institute and the Anthropological Museum in Cambridge. He acquired PhD degree at King's College in Cambridge University under R. A. Fisher in the year 1948. He also obtained Doctor of Science degree from Cambridge in 1965. Rao has received over 30 honorary doctoral degrees from university in 17 countries around the world and numerous awards and medals for his contribution to statistics and science. His professional experience includes over 40 years at Indian Statistical Institute as superintending statistician, head of research and training school, director of RTS, secretary and national professor. He has more than 20 years of experience at universities in USA, UK, including the University of Pittsburgh, Pennsylvania State University, University of California at Berkeley, Johns Hopkins University and Cambridge University. Rao developed research and training programs and produced several leaders in the field of mathematics. On the basis of Dr. Rao's recommendations, the Asian Statistical Institute, now known as Statistical Institute for Asia and Pacific was established in Tokyo to provide training to statisticians working in government and industrial organizations. He joined American Statistical Association in 1970 and was honored 2 years later with election. Was honored 2 years later with election to fellow of 2 years later with election to fellow for outstanding and profile contribution for his devoted statistical teaching and service. The American Statistical Association Petersburg chapter, named after its statisticians of the year 1981. In the year 1989, he was awarded the Samuel S. Wilkes Medal for his outstanding contributions to statistics. In 1997, he received the Distinguished Achievement Medal from American Statistical Association section on statistics and the environment for outstanding contributions to development of methods, issues, concepts and applications of environmental statistics. In addition to his extensive American Statistical Association activities and awards, he is a member of 8 national academies in India, UK, USA and Italy. He has been elected Fellow of Honorary Member to 26 Statistical Mathematics of Science or Mathematics of Science, Statistical Mathematics of Science organizations. Since 1943, Rao has received dozens of medals. Citizen Rao received dozens of medals, citation award and other honors from his valuable contributions to statistics and science. In 2000, the Mayor of Kent proclaimed May 12 as C.R. Rao's Day and presented him with a key to the city. The Government of India instituted a national award in honor of Rao to recognize and reward young statisticians. Rao has served as president of 5 statistical societies: 1 Indian Econometric Society, 2 International Biometric Society, number 3 Institute of Mathematical Statistics, number 4 International Statistical Institute, and 5th Forum for Interdisciplinary Mathematics. He has devoted his full life till today for promoting statistics and their usefulness in society. In his own words, Rao states, if there is a problem to be solved, seek statistical advice instead of appointing a committee of experts. Statistics can throw more light than the collective wisdom of the articulate few. Among his best known discoveries are the Kramer-Rao bound and the Rao-Blackwell theorem, both related to the quality of estimator. Other areas he worked include multivariate analysis, estimation and differential geometry. His other contributions include Fisher-Rao theorem, Rao distance and orthogonal arrays, etc. He is the author of 14 books and has published more than 400 journal publications in the most reputed journals of the world. Several statistical terms and equations are named after Rao and are regularly incorporated into textbooks and other statistical publications. In addition to his own work, he has been the PhD thesis advisor for more than 50 students and has helped thousands of others through teaching and monitoring. Statisticians and scientists across the world have celebrated Rao's long career in statistics. There have been 9 special issues of journals from India, USA and UK during last decade celebrating his life and works. There have also been 6 special conferences in honor of Rao since 1980, usually coinciding with his birthday. The Times of India choose Rao as one of the top 10 scientists in modern India, considering all discipline and the impact of work done by each scientist. Rao has worked with such famous statisticians as Blackwell, Fisher, Niemann, Hamilton and Rubin, and dozens of theorems of his credit. He is fellow of Royal Statistical Society. Government of India has awarded him with Padma Vibhushan in 2001. He was awarded with the National Medal of Science at White House on June 12, 2002. It has been more of the most prestigious award of the time, which is given to the individuals for doing pioneering scientific research work that has enhanced our basic understanding of life and the world around us. In his honor, the Pennsylvania State University has established C.R. and Bhagwati Rao Prize in Statistics. Also, there is C.R. Rao Advanced Institute of Mathematics, Statistics and Computer Science. C.R. Rao's areas of research contributions can briefly be mentioned as under: estimation theory, statistical inference and linear models, multivariate analysis, combinational design, biometry, generalized matrix inverse, functional equations, etc. Today, he is a living legend whose work has influenced not just statistics, but has had far-reaching implications for fields as varied as econometrics, genetics, anthropology, geology, national planning, demography, biometry and medicine. Awards and medals: International Mahalanobis Prize in the year 2003 of the International Statistical Institute, Srinivasan Ramanujan Medal in 2003 of the Indian National Science Academy. President George W. Bush on June 12, 2002 honored him with the National Medal of Science as a prophet of New Age, with the citation for his pioneering contributions to the foundations of statistical theory and multivariate statistical methodology and their applications, enriching the physical, biological, mathematical, economic and engineering sciences. Padma Vibhushan 2001 by the Government of India. Mahalanobis Centenary Gold Medal in the year 1993 of the Indian Science Congress. Wilkes Memorial Award in the year 1989 of the American Statistical Association. Meghat Saha Medal in the year 1969 of the Indian National Science Academy. Guy Medal in silver in the year 1965 of the Royal Statistical Society. S.S. Bhatnagar Award in the year 1963 of Council of Scientific and Industrial Research. J.C. Bose Gold Medal for the Bose Institute. Gold Medal of the University of Calcutta. He was also awarded an honorary Doctor of Science by the University of Calcutta in 2003. There is a one institute in Hyderabad named after him, and also the road where the institute situated known as C.R. Rao Road. Rajchandra Bose. Bose was born on 19th June 1901. He was an Indian American mathematician and statistician best known for his work in the design theory and the theory of error correcting codes, in which the class of BCH codes is partly named after him. He was notable for his work along with S.S. Srikhande and E.T. Parker in their disproof of the famous conjecture made by Leonard Euler that there do not exist two mutually orthogonal Latin square of order 4n plus 2 for every n. Bose was born in Hoshangabad, India. He was the first of 5 children. His father was physician and life was good until 1918, when his mother died in the influenza pandemic. His father died of stroke the following year. Despite difficult circumstances, Bose continued to study, securing first class in the Master of Science examination in pure mathematics at the University of Calcutta. His research was performed under the supervision of geometry professor Shyamadasa Mukhopadhyay from Calcutta. Bose worked as lecturer at Asutosh College, Calcutta. He published his work on the differential geometry and convex curves. Bose's course changed in December 32 when P.C. Mahalanobis, director of the Indian Statistical Institute, offered Bose a part-time job. Mahalanobis had seen Bose's geometrical work and wanted him to work on statistics. The day after Bose moved in, the secretary brought him all the volumes of Biometrica with a list of 50 papers to read, and also Fisher's statistical methods for research workers. Mahalanobis told him, "You are saying that you don't know much statistics, but you master the 50 papers and Fisher's book. This will suffice for your statistical education for the present." With S.N. Roy, who joined the Indian Statistical Institute a little later, Bose was the chief mathematician at the institute. He first worked with multivariate analysis, where he collaborated with Mahalanobis and Roy. In 1938-39, Fisher visited India and talked about the design of experiments. Roy had the idea of using the theory of finite fields and finite geometry to solve problems in design. The development of a mathematical theory of design would be Bose's main preoccupation until the mid-1950s. In the year 1935, Bose had become full-time faculty at the institute. In 1940, he joined the University of Calcutta, where C.R. Rao and H.K. Nandi were in the first group of students he taught. In 1945, Bose became head of the Department of Statistics. The university authorities told him that he needed to have a doctorate, so he submitted his published paper on multivariate analysis and the design of experiments and was awarded Doctor of Literature in the year 1947. In 1947, Bose went to the United States as a visiting professor at Columbia University and the University of North Carolina at Chapel Hill. He received offers from American universities and was also offered positions in India. The Indian job involved very heavy administrations, which he saw as the end of his research work, and in March 1949 he joined the University of North Carolina at Chapel Hill as professor of statistics. In the years at Chapel Hill both made important discoveries on coding theory with D. K. Rai Chaudhary and constructed with S. S. Srikhande and E. T. Parker a Greco-Latin square of size 10, a counterexample to Euler's conjecture that no Greco-Latin square of size 4k plus n exists. In 1971, he retired at the age of 70. He then accepted a chair at Colorado State University of Fort Collins, from which he retired in 1980. His final doctoral students finished after this second retirement. Both died in Colorado at the age of 86 in the year 1987. Today we have seen the biography of the well-known statisticians of the world.
स्वाध्याय टीवी